Welcome to the engineering measurement course. So this is experiment number 8. We are computing the bending moment using Matlab. So as you know, as a civil engineer, how much important it is to compute the bending moment and shear force in a structure. Because when we find it out that the dimensions of beams or how many reinforcements are required in a beam or a column, for that we have to find it out the bending moments first. Once we know the loads on a beam or column, we have to find it out the bending moment and shear force, and after that draw we can find it out the dimensions of beams, columns, or how many reinforcements required, all these parameters. So in this experiment, I'll demonstrate with a small example how to calculate or how to compute the bending moments using Matlab. So normally what happens is if we do a single beam or a two beam, we can do it calculations by manual hand. We can compute the bending moment and bending moment diagrams using by simple hand calculation. But for the real structure, if you see, real structure is composed of multiple beams or multiple columns. So in that case, it is very difficult to draw the bending moment and shear force diagram by hand. So for that we need some computer program. So here I will demonstrate you with a simple code how to write code in Matlab to compute the bending moment and shear force. So before we get into our actual coding part, let's get understand few basic things about the concept here. So there are many types of beams. So first one is cantilever beam, second one is simply supported beam, third is overhanging beam, fourth is fixed beam, and fifth is continuous beams. So which one is cantilever beam? I think many of you have seen this type of structures, right? So this type of structures we call it so this type of structure we call it a cantilever beam. Means one hand is embedded on a wall, right? If you see, this is dotted line is embedded on a wall, and another end is free. So this type of structures we call it, or this type of beam we call it cantilever beam. Means one end is embedded and another end is free. Similarly, if you see this beam is simply supported on a two support. So this is one support, this is another support, and this beam is simply resting in between two supports. So this beam we call it simply supported beam. That is second case. Now third case is overhanging beam. So now you can see this beam is simply overhanging, right? This portion is hanging outside. So this beam we call it overhanging beam. And similarly, our fourth category is fixed beam. So when the both ends of a beam are embedded on a structure, that beam we call it fixed beam. And then if the beams are continuous with multiple supports, then we call it fifth one, that is continuous beam. So you can observe in any structures, whether you are sitting on a multi-story building, or or if you go to bridges or shopping malls, anywhere you will see beams, and beams either it will be in one of its type, either it may be cantilever or simply support or fixed, overhanging or continuous, whatever it may be. So these are different types of beams. And now another important thing is load. So now we understood what are the different types of beams are there in general, and the loads also, what are the loading patterns. So loading also, there are broadly there are three categories of loading. One is concentrated loading, and second one is uniformly distributed loading, and third one is uniformly varying loading. So these three are also again very general types of loading. First one is if the loads are acting concentratically with W, then we call it is a concentrated load. But if the loads are distributed all along the length of the beam, then we call it uniformly distributed load, or UDL. And this is uniformly varying load. So load is varying from one end to another and linearly again. So this is uniformly varying load. So these are the three different simple cases. But in reality, if you find, the beams will have different types of complex loading. It may not be a simply concentrated loading, or it may not be simply UDL, or it may not be simply UVL. It may have different varieties of loading. Okay, so that's how the things goes. So these are the basic loading patterns. So from here we can develop the complex loading, and we can find it out the bending moment and shear force. So in this experiment, basically I'll show it to you how to do that using Matlab, how to compute the bending moment and bending moment diagrams. So if you take, this is a simply supported beam with one hand, both the hands are that simply two. This is one support, this is another support, and this is the beam is resting in between these two support, and a concentrated load is acting, that is 1000 Newton. So because of that, how much bending moment will be generated? So again, bending moment, already you have studied in your 12th standard and in the first year classes also, that bending moment is nothing but force into distance, right? So that is moment. Force into distance, we call it moment. So we have to compute first the reaction forces, because we know this is a beam, and length is also given. Total length of the beam is 4 meter, that is 2 meter plus 2 meter, right? 4 meter. And the load is concentrated load is acting just at the center of the beam, and we are considering this is simply support. So this is one support, this is another support. So total load is 100 newton. So how much load will be coming into this support, and how much load will be coming into this support? That is the first question, or first thing we have to find it out. Reaction force, that we call it. So we call it reaction force Ra and Rb. So these two parameters. So how to find it out, Ra and Rb? That is already using the equilibrium equation we can find it out, the Ra and Rb. So how to compute Ra? Ra and Rb will be simply Ra equal to P into L minus X by L. What is X? X is from A to where loads are Xing. So here it is at the center point. So X will be simply 2 meter, right? So X is a variable, means where this concentrated load is acting. So we are just deriving the equations. So for that we used capital X. Okay, so here in this case capital letter X will be 2 meter, right? Because 2 meter it is acting, and L is the total length of the beam. Similarly, Rb also you can easily compute using that equilibrium equations, which is nothing but P into X by L. Okay, now if we are computing the bending moment, now that is our main objective of this experiment, right? To compute the bending moment. So to compute the bending moment, so here if you see, so bending moment will be, now we understood force into distance, right? So if you are finding out bending moment at this point, XX section, if you see this is a section, right? Here if you find it out, the bending moment means you have to go to either left side or right side, any side you can take and you can compute. So let's compute, let's take it from the left side, because left side of XX plane only one load is acting, right? Which is nothing but a reaction force. So the moment is force into distance, right? So force is Ra into distance. So distance is from here to here. How much is distance? That is the moment at XX over. So the moment at XX, MY I denoted it, equal to Ra. Ra is this reaction force, vertical reaction force, multiplied by this distance. Okay, so this distance is, if it is 1 meter, that's then it will be Ra into 1. But if we don't know, I mean, if it is a variable also, we can denote it another variable with y. Okay, y is nothing but this distance. So here it is 1 meter, but in other case it may be different. So let's assume this is also as a variable. So that's why Ra into y will give you what is the moment at this section. So now this section, if this section, this equation will be valid until and unless the loads are on the right side. Means here if it is load is there, then this formula is valid. So from the left side of this load, so from A to C region, this formula is valid. Now if you find your moment at this section here, maybe after the load here, then what will happen? So you'll have now two forces in the left side. One is Ra, another is this load also P. So in that case, the My will be what? So if we now the bending section is here, so bending moment at this point, My will be force into distance. Our formula is same. So force is Ra into distance is Y, capital Y, right? Ra into capital Y is positive, which is nothing but a clockwise direction for a moment is acting, and another force is acting which is anti-clockwise, right? It is 1000 Newton, and it will be anti-clockwise because we are finding out here at this section what is the bending moment. So in that case, it will be P into this distance from C to the section where we are finding out. So that is P into that, from here to here it will be total is Y minus from A to C is X, right? So Y minus X. So this is the formula of My. So My is equation is valid for the right hand side of the load. Okay, right hand side of the load, this is the equation. So these are the two very basic equations we just derived. So I am not going into in details about the derivation part. I just quickly explain to you, because here our main objective is to write the code for using these two, I mean, equations and all. So now let's go to Matlab and write a script to execute these two command. So I am just going to Matlab, and then we'll try to explain. So Matlab is already opened in my system. So uh, already we discussed what are the basic syntaxes of the Matlab. So Matlab, you can understand that so what are the variables here? Let me go it here also. So first we have to find it out Ra and Rb, right? Ra and Rb is what? The reaction forces, Ra and Rb. So which is nothing but P into L minus X by L, right? So now if you go, so we have to define what is the value of P. So let's, for the same example I have taken, so sorry, not same, similar, but here P is 1000, right? So anyway, I have just considered the P is 100 for example, and X means where the load is acting, so here in this case it is middle, but I have considered here some other. So X is, we considered is 3 meter from the left hand side support, and L is the total length of the span, which is 10 meter, and Y is where we are finding out the bending moment, at which section. So like here, so here X was 1 meter, right? Here in this section we are finding out the bending moment. So now it may be any value, so I just used a random value of 6 meter. At a distance of 6 meter, I am finding out, I want to find out what is the bending moment. So these are the 4 values we just assumed. Okay, P is the load, X is where the concentrated load is acting, L is the total length of the span, and capital Y is the total duration. Sorry, capital Y is the where we are finding out the bending moment. And this to command, clear command will give you, if you want to remove any variables in the workspace. So currently it is empty, but in your case maybe earlier also some variable may be there. So in that case, using clear command, you can clear all the earlier past variables in the workspace. And CLC command is, it will clear the screen, right? So here maybe so many things will be coming on a command window, right? Just so if I want to remove all these earlier commands, so this is the command, clear command. So CLC will give you, it will clear everything. So this two is just a protocol where I am keeping it in every script. And then I define this 4 value. Now we have to compute RA, right? What is RA? So RA was P into L minus X by L, right? So same equation we have to write it, P into L minus X by L. So see, same thing I have written it here also. Now what is RB? RB is nothing but P into X by L, right? So RB is P into X by L. Same thing I have written. So now the main trick start. So here see my, so moment will be different. So one is for the left hand side. When the section is left hand side of the support, left hand side of the load, then we'll have this equation. But if the section is right hand side of this concentrated load, then we'll have another equation, right? So these are the two different equations here. So that's why we have to use a condition, if else condition. If the section is here, then the equation will be this one. But if the section is here, then we have to use this equation, right? So that is the if condition we have to use it. So now if you say, I have just used simple if condition in the Matlab. So if X, what is X? X is where the capital X is where the load is there. So load is at 3, okay, at 3 meter. And what is Y? Y means at which location we are finding out the bending moment. Okay, so now here if you see, X is now 3, and Y is 6, means the section is after the load, right? Y is more. That means we have to follow this equation. So this equation we have to follow it anyway. So before writing the script, if X is greater than Y, means the section is left hand side of the load. If the first case is there, then what is the my, moment at Y, will be simply RA into Y, right? So that is the thing, first equation, RA into Y, if it is left hand side. But if it is right hand side, then this will be the equation. So that's what. So if X is greater than Y, then this is the simple equation. And else means in other case, my will be another equation. So another equation is nothing but RA into Y minus P into Y minus X. So this is the simple equation, and you have to use the AND to end the if loop. So very simple if loop we have written here, just to use either first equation or the second equation, either it may be. So now if you run this script, so you will get my, quickly it will give you 120. So how we got it? So here if you see, let me quickly verify the value whether my is really 120 or not. So P is given 1000, right? So X is here 3 and Y is 6, means we the section is right hand side of the, because Y is more, right? So section is here right hand side of this load, means you have to use this equation, or the formula should use this equation here. So what is RA into Y? So RA value is how much? So RA value will be, from workspace you can see RA value is 70. 70 into Y, capital Y is 6, 70 into 6 is 420. So 420 minus P into Y minus X. Y minus X is how much? Y is 6, X is 3, so 3. So P is 100, so 300. So 420 minus 300 is nothing but 120. So that's our answer is correct. Okay, so this is a very simple script to compute the bending moment, a very simple bending moment. Now let's draw a diagram, bending moment diagram. So how to draw the bending moment diagram? So now what we computed is at a static section. If the section is here, then this is the equation. If section is here, then that will be the equation. But now if I want to draw the bending moment diagram, diagram means at every instant how the bending moment changes. Okay, so now if the section is here just above the support, then what will be the bending moment? If this section or the where we are finding out is here, then what will be the bending moment? Now if this section is moving from left to right and we are computing what is the bending moment at each instant, and then we plot it with respect to the total length, then we got it bending moment diagram. Means the section where we are finding out the bending moment, it is moving from left to right. Okay, so at the beginning x will be 0, xx, that is the, sorry, not xx, y actually, basically y is the moment, right? Y will be 0, then gradually y is 1, 2, 3, like that multiple times. If you increase the y, how the x will be changing, that we are computing. So that is bending moment diagram. So this is a very simple script. I would recommend everyone, please write this script in your own and try to execute it, whether you get the correct answer not or not. So now here P is also static, so P is not changing. X means where the load is acting, that is also static, that is 3, not changing. L is the total length of the beam, which is also same, that is 10. Okay, but the changing here I am changing is y value, capital Y value. I just created a different variable y1, which will be changing from 0 to L, and every increment will be 0.5. So basically I am creating a vector or array. Okay, basically y value I am changing. So at the first instant, capital Y value will be 0. Second instant, the capital Y value will be 0.5. Third instant, capital Y value will be 1. Fourth instant, capital Y value will be 1.5. Like that, the loop will continue up to 10. L means 10, right? So basically I have to run a loop, right, to execute this one. So simply I have written a for loop for that. So see, the for I is a variable to run the loop. I is equal to 1 to length of yi. So yi means the loop will be running how many times? The loop will be running uh, the total how many values are there in the yi. So yi total how many values will be there? So L is 10, right? So total 21 values will be coming in y1. So this loop should continue with 21 times. That's why I is equal to 1 to length of y1. Length of y1 is nothing but 21. This value will be coming. So 21 times this loop will continue. Now what is first value? Y. So y value is first instant. In the first loop, y value will be taken as 0. Okay. So let me execute this y1. So and you can see the variable here. So now you can see y1 has created in the workspace. So if you see what is there inside the y1, so y1 is nothing but array starting with 0, then second value is 0.05, then 1, 1.5, 2, okay, 2.5, like that it will continue up to 10. Okay, up to 10 it will be there. So that's how I did that. So y1, so at the first loop y will be 0. So in the second loop y will be 0.5, like that y will be changing. So that's why the loop also it will be, so at the beginning I is equal to 1. Okay, so I is equal to 1. So y value will be yi variables first value. I is 1. So first value is what? 0, right? So if you see, the first value is 0. So at the first loop y value, capital Y value is 0, and then the entire script whatever we just derived here, bending moment, it's entire script I just copy pasted here. So it will compute what is my, that is bending moment at first step. First step means when the y or the section is at the 0 location. So that value will be stored. So that is first loop. Now in the second loop I value is 2. So capital Y value will be yi2. So yi2 means, if you see, yi2 means this value. So now in the next loop y value will be 0.5, and this entire process will be continuing. So like that this loop will be running for next 21 times, and the my will be developed. So my is nothing but the bending moment when the section at different locations. At the beginning section is at the 0, 0. In the next loop 0.5, like that the loop will continue up to 10, because total length is 10, right? And then we got multiple my, and at the end simply we are plotting with yi means at the different location of sections and what is the bending moment. So we are simply plotting. So this is a very simple code. We just written it in a loop format, and if we run it, if you get, this is a bending moment diagram. So bending moment, now you understood bending moment will be maximum at the, because where is our load? So our load is at 3, right, at the center. That's why if you see the bending moment also is maximum at 3. So this location is at 3, the bending moment is maximum, and then again bending moment is gradually decreasing. So that is the bending moment diagram. We get it. So now if we change this to 5, for example, or maybe 7, then you will see that peak also will be changing. So now if you see the peak also now went to 7. Okay, so wherever you are changing the bending moment of that concentrated load, there also it will be changing. So that's what that is how to use the loop to draw the bending moment diagram. Okay, so now see, this is, and this is the script for computing the bending moment, right? We have derived it in the first script. So this one, same script we are using, but we can reduce it, because every time we are computing bending moment, right? So it is always better to create a function instead of writing the same code repeatedly. If we can create a simple function, it will be very easy to do that. So how to do that? So this is the bending moment function, we have written it. So this first script, whatever is there, same thing, I just removed these values and I made it as a variable. So now if you see, I just written a function. So how to write, what is the syntax for the writing function? So function, what is the output? My equal to bending underscore moment. This is a function name. And what is the input it is asking? P, L, X and Y. So there is a 4 input it is asking, and the same code will be repeated here, and ultimately we get it the function. So that is a simple function, bending moment function. Okay, so same loop also, whatever we just computed, that also can be done using the as a function. So this is, I just see the entire code. So this is the bending moment diagram computation, right? Whatever we did it just now. So this plot, now using this function, see how it is very small code, it is hardly 5 lines or so. But here without function, see how it is almost 15 lines. But with the function, the same code is very quickly we are running. So we just p is given, x value is given, y value is, l value is given, and y also how it is changing. Now simple for loop, I is equal to 1 to length of yi, same code yi, but here I am using the function. Instead of writing the entire bending moment code, I am simply using bending underscore moment is a function. So automatically code will read this function and it will execute what is the bending moment. So at every loop, the my value, that is moment at y section, it will be stored, and ultimately we are plotting it. Okay, so now if you change it to maybe length is now increased to 20, and maybe x also, the location is at 11. So now if you run this code, uh, you will get the diagram. See the diagram, now that it is 20, up to length is up to 20, and at 11 you see the peak. Okay, so that's how we write the bending moment code in the Matlab. So similarly, you can try yourself for the other loading cases also. So whatever I have shown is only for the concentrated load, but in your case, I already discussed that different types of loads will be there. So like here, uniformly distributed loads are there, uniformly varying loads are there. I would request you to write a code on uniformly distributed load, UDL, and compute what is the reaction fast. First you write this equation, then once you write the equation, you just simply code it in the Matlab and you will get the final value. So that's how we do in Matlab, how to for bending moment and shear force computation, and as well, only bending moment. So in the next lecture I will be discussing about how to draw the shear force diagram in a Matlab. Thank you.